This is a quick explanation of some changes to the IVK Skill API in version 2. Previously, we compared all players in a match against each other, but now in version 2, we compare players based on when or if they were in the match together at the same time. The reasons for this are to improve skill ratings in games that allow players to join matches already in progress or to rejoin after being disconnected. This system can also fairly compensate players in ranked modes when their teammates quit early. Instead of processing a list of players in the match like in version 1 in the left column, we now have a list of sessions, shown in the right column, with one or more sessions per player. To illustrate how we use this session data, let's say we have 3 players. The first player simply plays the entire match, the second player joins the match late and leaves early, and the third player gets disconnected in the middle but rejoins near the end. The first thing we do is identify all of these events, or state changes, where players either join or leave the match. Then we can examine every interaction period or encounter between every combination of players. All of the encounters between any 2 players can be aggregated and summarized into a relationship between just those 2 players. In this specific case, these 2 regions are all the encounters of player B with player C. Doing this for every combination of players leads to a relationship matrix which describes, first of all, the expected outcome of every player versus every other player, which is kind of like the probability of a player outperforming the other, and then second, the actual outcome between those 2 players, which usually means comparing their score per minute and normalizing it from 0 to 1 one way or another. And then lastly, each relationship includes all the data we need to evaluate how important that relationship is. Most obviously, that's overlapping time, but it will also include the uncertainty of the ratings, as well as different weights if players are on the same team, or in the same party, or if one of them is a bot. Finally, we can take each player's relationships and squash them into a single result per player. So we reduce each row into a single result, which tells us things like how we expected each player to perform in the match, how they actually performed, and what their new skill rating should be. As a side note, you might notice that we compare players against themselves and wonder if that makes sense. And the answer is, it does, sometimes, depending on the details of the underlying skill model. Basically, it's an easy way to account for different sample sizes, so that being the best player in a match with 100 players is rewarded more than being the best player in a match with only 2 players. Quick example. Player A had 50 points per minute, player B had 100, and C had 20. We can convert that into a binary outcome matrix, where 1 means a higher score, 0 means a lower score, and 1/2 equals a tie. If we give 0 weight to self-comparisons, we'll always end up with weighted average outcomes from 0 to 1, regardless of the number of players in the match. But if we give equal weight to self-comparisons, the resulting outcomes will be at the midpoints of equal size partitions. Or if we gave self-comparisons twice the weight as others, we'd subdivide the range from 0 to 1 with perfect intervals. Anyway, for modes that can have different player counts, like Battle Royale, it can make sense to normalize the outcomes this way. But to get back on the main topic, the other thing we do with session data is model the team interactions. Like with the player versus player case, we construct events when the teams change, and we use those events to partition the match into a series of encounters between teams. Just like with players, all the encounters between every pair of teams is summarized into a relationship with net expectations, outcomes, and weights, which again forms a relationship matrix that we can similarly aggregate into per team results, which in the case of 2 teams is pretty straightforward. The player results from before are then combined with the respective team results to arrive at the final rating updates. I'm skipping over quite a lot of details there, but one cool thing is that players can theoretically switch teams mid-match and still get fair rating updates. And one last side note, when it comes to ranked play, we can adjust your ratings appropriately if your teammates leave early, but we still don't want the other team to be able to sabotage your rating update by rage quitting themselves. So even if one player on the other team drops out, we evaluate their skill from your team's perspective as though they were always at full strength. Anyway, that's all for this video. Reach out if you have questions. Otherwise, like, comment, and subscribe.